Hi guys, welcome to the class. Everyone, please confirm once that am I audible to you or not? Hi, good evening Satna. How are you? Shillong, are you there? Satna, am I audible to you? Okay. Hi Shillong. What's your camp port? Okay. What was the last topic we were discussing? Hydrogen bond is over. Okay. I guess so I have told you that we have to discuss about the resonance, na? Hi guys. Okay, yeah, HCl as well, na? Okay. Getting. Okay. Guys, look at this. If you say there are two HCl molecules, obviously they are polar in nature. I'm taking another example. See. Delta negative, delta positive, delta positive, delta negative, delta positive, delta negative. Now guys, look at this. There must be a force of attraction between these two. There is a force of attraction and there is also force of attraction. Now, observe one thing that here this force of attraction is between Cl and the H. Okay. Now, actually, what is this? What actually I would like to say here that this attractive force is not very strong over there because of the size differences. Okay. Now, if you talk about this one, that there is a force of attraction between the fluorine and the H. Here, the force of attraction is between hydrogen and the Cl. Okay. Again, if we talk about the HF and the H of the HCl, there can be hydrogen bonding. Yes, if we talk about the HCl and the HF, in this molecule, there can also be what? Hydrogen bonding. Okay. But the problem is, due to the size differences, let's say suppose this is A and this is B. This is A and this is B. Due to the very due to the large difference in sizes of the chlorine and the hydrogen bond which is formed between the B, means if we talk about the B type of hydrogen bond, this is very weak as I compared with what? A. Okay. Because in the A, the size differences were very less and the electronegativity was really high, due to which there is a development of charge, and that development of charge is actually prepares, or we can say have a very strong hydrogen bond. Okay. But if you observe the first molecule, In the first molecule, there is a hydrogen bond of Cl and H. Okay. Now, the problem is both the molecules are HCl. Okay. So, guys, you have to remember one thing, that whenever there is a HCl molecule over there is HCl, two HCl molecule are over there, you won't say it is a hydrogen bond. Okay. This is not hydrogen bond. Okay. Sorry. This is not your hydrogen bond. Okay. Why? Because of the size differences, the development of charge was not too good over there. Okay. In short, if I would like to summarize it to make it much more clearer, you can say that this is your HX. X can be your nitrogen, oxygen or fluorine only. Then the another atom, let's say suppose this is Y. Now the condition is what Y can be to exist as a hydrogen bond. This can be your nitrogen. Sorry. Not F, this is Y. If we talk about this one, then this can be your what? Nitrogen, oxygen, fluorine, or you can say chlorine. Okay. So ultimately, just focus on this one. Okay. And H of the another molecule. Okay. If you say that HX and means, I would like to say that between two HY molecules, there cannot be the hydrogen bond. But yes, between two HX molecules, there can be the hydrogen bond. Okay. So that's what actually I was trying to say. See, this is nothing but the example of HY type of molecule. This is HY. This is also what? HY. Okay. That's why there will not be the hydrogen bond. But yes, in this case, there will be the hydrogen bond. Okay. Got it, this one? Guys, have you got that? Shillong. Okay, so that's what actually I was trying to say. You can copy this one, no? Now, I hope so it is clear to everyone that only HCl cannot form the hydrogen bond, but yes, if against of HCl there is another molecule which is in which the hydrogen is bonded to the very high electronegative element, then there is a possibility of the hydrogen bond, and again that will be really weak. Okay, so please copy this one. Done? Thank you. Okay, so now let's start with the resonance. Guys, just look at the screen, need not to copy anything. Okay, just look at the screen. I am drawing the Lewis dot structure of the O3. And O3 can be written like this. Okay. I'm saying this is atom 1, this is 2, this is 3. Okay. I'm drawing another structure, keeping the position of oxygen same. See, 1, 2, 3. Now you have to tell me what is the difference between these two structures. What difference are you observing over there? Is there any difference between these two molecules, or are they same? Position of double bond. Okay. Means they are different, na? Arrangement of bonds. Yes, very good. Yes, they are different actually. So that was the problem actually with the Lewis dot structures. Okay. That if I fix the position, if I talk about the Lewis dot structure, there is a no difference. Truly speaking, if we are talking about the Lewis dot structure, both are absolutely correct. No problem no problem at all. But we know that double bond have the lower bond length as I compared in respect to the single bonds. So in the first case, there is single bond between 1 and 2 atom, whereas in the second case, there is single bond is between 2 and 3 atom. Okay? According to that concept, according to Lewis concept, that bond length should be fixed, na? See, 1 and 2 should have a fixed bond length. Okay? But if you check out the second structure, that bond length is changed actually over there. Similarly, if you check out the bond length of between the atom number 2 and 3, this is again changed when I draw the second structure. Okay? So I can say that one of the structures cannot determine all of its properties accurately. Okay? Means if I would like to determine or read about the properties of this molecule, I should consider all these molecules. Okay? So that's what actually the problem. To overcome with that, we have introduced the concept of resonance. Means concept of resonance simply says that whenever a single structure cannot determine, or we can say cannot tell about every property of a molecule, means there is a possibility of more than one Lewis dot structures, and each individual Lewis dot structure can have certain properties. Okay, and after that, like we calculate the average. Okay, and after that, if we draw a final structure which explains all the individual structures, is known as what? Resonating hybrid, or we can say the resonance hybrid over there, which means that this structure is ultimately the final conclusion of all those relative structures over there. Okay, so this is what the resonance is. Let's say suppose this is the symbol of resonance. First of all, this two-sided arrow. Okay, now I'm drawing the resonance hybrid. See, if you have observed one thing, that in this one, position of O is totally fixed, as well as one single bond is also fixed over there. I hope so it is clear to everyone that position of atoms is not changed, as well as position of bonds, single bonds, is not also changed. But yes, double bond is changed over there. So I can say double bond was initially here and finally here. This dotted line is actually representing that double bond was shifting between these two atoms. Okay, so this is actually the conclusion of the first two structures, resonance hybrid. Okay, it is clear to everyone? Please confirm me once. This is a resonance hybrid. I'll write its statement as well. This is your resonance hybrid. First of all, tell me, are you clear with this one? Please copy. Done? Shillong? Okay. So guys, whatever I have explained to you, I'm writing it for you. Please copy this one. It has been observed that properties of certain compounds cannot be satisfactorily explained by writing a single Lewis structure. The molecule is then supposed to have many structures each of which can explain most of the properties of the molecule. But none can explain all properties of the molecule. The actual structure is in between of all these contributing structure and is called resonance hybrid, and the different individual structures are called resonating structure. In short, you will write it as a RS or canonical form. This phenomena is called resonance. Please copy and then confirm. Shillong, mark your attendance, please. And after copying that, just confirm me once. Yes, Shillong, I got it. 12 students, yes. Very good. Have you copied, Shillong? Okay. Condition for resonance. Or you can copy these conditions with me, then after that I'll explain all the conditions by the help of the examples. Okay. First, position of atoms is fixed while writing resonating structures. Next, there is transfer of pi electrons only. Next, there is no involvement of sigma bonds in writing RS. Next, conjugate system. Molecule must be planar. Planar means each atom should be either sp2 or sp hybridized. Next, presence of conjugate system. The question is what conjugated system is. Okay, so I'm writing the conjugated system. Just copy with me. Remember guys, A, B, C, D are the atoms, nothing else. Okay, single bond, double bond, single bond, double bond. Just you have to keep in mind this one. Okay, this is your sigma bond, this is pi bond, sigma bond, pi bond. Okay. Then this is the free radical. Means when there is only a single electron present over there in a on an atom, it is the free radical. Okay, so just copy these conditions, and after that, keep your pen inside your notebook. Keep your notebook in your side. Be relaxed. Just look at the screen and then enjoy the resonance. Okay. Just but before that, just confirm me once that have you copied that. Okay. Otherwise, only I will enjoy over there. I'll just look at you. If one thing is that net is not too quick over there, so I cannot notice your expressions as well. Okay. So even I cannot enjoy as well. So it's better that you should enjoy. Satna copied. Satna, are you there? By the way, is that guy present in today's class, Shillong? Okay, Satna has done. Okay, we will talk about that guy. Okay. So guys, what you have to do, just look at the screen. That's it. That is not a joker, dear. I mean, the student who cracks a joke, okay? Don't consider him as a joker. He's a really nice guy. Okay. Whenever he comes to the class, just let me know. Okay? Okay, so guys, just look at the screen and observe what I'm trying to do. I'm telling you again that it is going to play a big role in the organic chemistry. Okay? And it has a very importance of the resonance, how to write the resonating structures, and on the on the basis of the resonance, you will definitely get a question, definitely over there. Okay. So I'm taking examples. How to draw the resonating structures. First, let's say suppose I have got Cl, CH2, not CH2, this is CH. These are the lone pairs. Okay. Now guys, what we have to do, we have to check out that each and every atom should be the sp2 hybridized or sp hybridized. Okay. So by default, whatever questions I'll picked up, all will be the planar in nature. Just to check the planarity, you should check out the sp2 as the sp hybridized atom. Okay, so you won't do that. Okay, you will just see how you will write the RS, means resonating structures. Okay, to write the resonating structures, just keep in mind one thing, that the molecule should follow one of these 5 conditions. One of these 5 conditions. Okay, whatever condition, means out of these 5, any one condition can be followed over there. Now, if you check out this given molecule, see, there is an atom, chlorine, which has a lone pairs. After that, there is a single bond. Some atom are there. Let's say suppose this atom is P. I know that is CH over there. Okay, so I'm just writing it as a P. Then double bond and then Q. Just look at this. This is actually following the case number 3. Okay. Remember, guys, I have written only a single lone pair. It means that at least there can be a one lone pair. More than that, yes, it is possible. But there must be at least one lone pair. Okay. Now check out this one. This one is actually following the case number 3. Okay. Now, what we have to do? Starting from the Z. Z means this one, this one, this one, and this one. Okay. Starting from the Z, mark the numbers 1, then 2, and then 3. Means actually how to mark the number? Z should be the 1. After the Z, the next bond should be the single bond. Okay. After that, single bond means next bond should be what? Sigma bond. After that, the next bond should be the what? Pi bond. I'm repeating. After Z, the next bond should be the sigma. I'm repeating, the sigma. And after that, the next bond should be the pi bond. Okay. Now, after doing that, what you have to do? You will redraw this structure. First of all, you have to put this sign of the resonance. You will redraw this structure. All atoms should be at the same positions along with the single bonds. So, first one was chlorine, single bond, CH, single bond, CH2. This was my first work. Done? Now, what you have to do? Between 1 and 2, initially there was a single bond. Now, between 1 and 2, you will change the position of the bond. Means, the single bond will become the double bond and double bond will become the single bond. Okay? Means, between 1 and 2, now I'll put one more bond. Between 2 and 3, there was a double bond initially. Now I'll convert that double bond into the single bond. So that I have already done over there. Okay? So this is my resonating structure that has been prepared. Now, this is still incomplete. Okay? This is definitely the answer, but not the complete answer. See how to write the complete answer. See? Observe, between Cl and CH, there is a double bond. We know that for the creation of a bond, I need 2 electrons. I need 2 electrons. So obviously, if you check out between chlorine and the CH, only chlorine is having the lone pairs. Means chlorine is having the electron pairs. Okay? So what is actually happening over there? That chlorine has given its electron for the bond formation. Look at this. Guys, these arrows are really, really important. Just understand them. Okay? What we have to do? Where I have make a new bond, I'll shift those lone pairs over there. Means this is showing that these two electrons are shifted here and prepared this new bond. Got it? Now, once this condition is achieved, see, I'm drawing it on the another path. Cl, CH, CH2. Still, I haven't removed that double bond between 2 carbons. Okay. Now, one thing. We know that whenever an electron is lost by another atom, any atom, it will develop a positive charge. Okay. So here, chlorine is losing one of its electrons. That's why it will develop a positive charge over here. And rest 2 pairs will remain as it is. Okay. So this is the positive charge, and this is your rest of the lone pairs. Now, if you check out this carbon, actually this carbon has got a 5 bonds now. 2 bonds here, 2 bonds here, and 1 bond is between carbon and hydrogen. So its octet is exceeded now, so I have to maintain that as well. So what will I do? I'll shift this bond to this carbon. Okay, so what will happen? That these 2 electrons has been shifted to that carbon. So this is the electron pairs. Now what's happening? That this carbon is taking the electron. This carbon is taking the electron of another carbon. That's why this one will develop a negative charge. Okay? And now this double bond will get converted into what? You have to remove this bond into the single bond. Okay? So, before that, I need to shift these electron pairs here. Okay? So, this is your actual resonating structures. That's how you can draw. Remember one thing, the net charge in the molecule should be the same. If initially there is a zero charge, in the final structure there must be the zero charge. If initially there is a plus charge, in the final structure there must be the plus charge. Okay. First of all, tell me, are you clear with the example number 1? Everyone please confirm me once. Are you clear with the example number 1? Okay. I'm taking another example. Just look at the screen. Let's say suppose we have got this one. CH3, C double bond O. Negative charge. Okay. In this one, you will check out. Okay, this question is for you guys. This is atom number 1. This is atom number 2. Tell me, which atom should be the Z? Oxygen first or oxygen second? Which oxygen should be the Z? 1 or 2? This is, you have to tell me. Okay. Shillong, what do you say? Good. Yes, definitely. 1 will be the correct choice for the Z. Okay. So just mark them 1, 2, 3. Because if you move on this side of the CH3, this is the single bond, but I need a pi bond. Means the conjugation should be what? Z, sigma bond, pi bond. Okay. Now, first of all, you have to do the same. Draw all the atoms with the single bonds. Drawn. Now, the situation of the bonds, which is initially at the 1 and 2, should be changed by the 2 and 3. Means 1 and 2 will develop a double bond, whereas 2 and 3 will develop a single bond. Okay. Now the question is, how is that possible? Okay. So what we have to do? I know between carbon and oxygen has the lone pair, so it will shift its electron here. Okay. Now, out of 3 lone pairs, 1 is gone, so obviously 2 will be left. Again, what we have to do? See, or draw it like this. This is 3. And between 2 and 3, shift this bond here. So this will become the single bond, and here you will develop a negative charge as well. Okay. So this is the only possible case. Now, how many of you are clear with the example number 2? Are you clear with the example number 2, guys? Please copy these two examples. Please copy these two examples. Copy and then confirm. After that, you have to attempt this question. Please attempt this question. Tell me the answer. Have you attempted that question as well? So here you can check out, this should be the 1, this is 2, this is 3. So this is the position, it should be like this. And after that, final structure would be this one. Okay, this should be the structure. Copy and then confirm. Okay, let's move on. Let's say we have got yes, we have got this case. CH2 double bond CH are positive. Okay. Even in spite of writing the R positive, you can simply write it like this. This is your CH2 positive. Okay. Again, what you have to do, you have to mark 1, 2, 3. Just remember this sequence 1, 2, 3. Okay. And write all the atoms. Okay. Now what you have to do, just change the position of the bonds. Single bond will become the double bond, and double bond will become what? Single bond. Okay. The question is now how to make the position of the arrows. Okay. In the case of the positive ion. So I'm simplifying it for you. CH2. See, what actually happens in the first case, do not copy this one first, just understand this. In the first case, this electron pair actually shifts on this carbon. So what happened? This one will create a positive charge, this one will create a negative charge with the lone pairs. And this is already positive, okay? Now there is an attraction between the opposite and the negative, okay? So what will happen after some time, this one will get shifted over there and this one will get converted into this one, okay? So in spite of writing this middle step, we won't write this step, and I'll simply say, just write it like this. That directly shift bond from between 2, 3 to 1, 2. Okay, that's what you can directly do over there in case of the positive ion. Please copy and confirm me. Is it clear to everyone? Guys, is it clear to everyone? Okay, please copy. If you have done that, attempt this question. Don't get scared by just looking at the molecule, okay? You have to do exactly the same. That's what we have discussed in the case number 4, nothing else. Just look at the question. Don't get panic. Keep calm and attempt that question, and then after that, just inform me once. Done? Okay. See, mark it as a 1, 2, and 3. And after marking that, just draw its structure. Okay. 1, 2, 3. Then positive charge should be on the third position. See what actually was happening, that the position of the charge was changing over there. And 1 will become neutral. Between 1 and 2, there must be the positive charge. And after that, this is definitely happened like this. How many of you have done the exactly same? Please tell me. Okay, good. Wow, nice ratio. Okay, attempt this question. What was the last number? 5, number 6. It's your turn now. Negative, negative. Please do this question. And after attempting that question, just inform me once. And we will learn now how to write the resonance hybrid, okay, in this example. Means you could write for the previous examples as well. Just copy or just attempt this question, then inform me. Okay. Shillong, have you also attempted? Okay, let's start. Just look at the screen, okay? This one I'm taking as a 1, this is 2, and this is 3, okay? So on the basis of this one, I can say this can be the possible structure. O, C, O, O, okay? So I'm not touching this oxygen, so I'll just keep it as it is. But yes, the numbers where I have marked it as a 1, 2, and 3, I'll change the position of bonds over there. This one should be a double bond. This one will be the single bond. Now, yes, change the position of charge as well. So, I guess so it should look like this, and this one should like this. Other than that, yes, I need to shift the bonds as well. So, this electron will definitely be here, and this electron should be here. How many of you have done the same? Satna, Shillong. Only why Shillong? What's happening? Are you still having some doubt? Okay, I'm getting. Wait. This is not the complete answer. Wait, do not rub or do not cross. Yes, I'm getting it, Satna, getting it. This is not the complete answer, guys. This is not the complete answer. I can take this one as also the another possible structure. See, I can consider this oxygen as well. Means I'm talking about this one. I can consider this one as well. Okay. If I consider this one, so this one should be the 1, this one should be the 2, and this one should be what? 3. For this, there can also possible a structure here and this one. Now this is the possible structure. Negative, negative. And now tell me, are you getting out of these 3 structures any 2 structures? Means out of the remaining 2 structures that I have newly drawn, are you getting any one of that structure? Just let me know. And how many students are getting that that structure? Okay, that's good, Satna. Now, Shillong, what is the number of students? Okay, so actually what I wanted to say, very good. I was saying that whenever in such cases, there is not restrictions, guys. You can get only a single resonating structure. There can be more than one structures, definitely. Okay. How? Just we need to get every time different structures from the previous one. If we are drawing the 3, all these 3 should be different. If you check out these 3 structures, if I mark hydrogens, if I mark the atoms, this is 1, this is 2, this is 3, and this is 4. Check out every structure and every position, I am getting the different structure. Okay? If we can get the different structure, that structure will be possible over there, and I need to draw all the possible structures. Okay? That's what actually I was saying. So, 1 second, 1, 2, 3, I'll redraw it. Okay? So actually, for this possible case, there can be the 3 structures. Okay? Now I'm drawing the resonance hybrid. So to draw the resonance hybrid, which is RH, first of all, draw all the atoms with the single bonds. Okay? After that, just check between how many atoms you are getting the double bond. Okay? Draw them with the dots. See, between this carbon and oxygen, I am definitely getting a double bond. Okay. And even this is present in the first structure only. And yes, between this one, I am also getting the double bond. And yes, between this one, I am also getting the double bond. Okay. So this is your resonance hybrid. Okay. This is your resonance hybrid. You need not to draw these lone pairs actually. Tell me how many of you have got this example? Please inform me once. Okay. You're supposed to say yes or no. Means, are you getting this? Okay. Yeah, I am supposed to say the okay. Okay, please copy. Copy and then confirm. You can draw the resonance hybrid for every structure previously that we have drawn. Now I'm giving you a question, guys. You have to draw its resonating structures, whatever different possible structures are there, and after that, resonance hybrid. Okay. I'll give you the cyclic structures. Okay. Because you guys are more smarter than me, na? So you should get a smarter questions. I'll do the easy questions. You will do the smarter questions. Okay. This is the question for you guys. Oh, wait. Not looking too cool. Not this one. A little bit better. Start. Draw all RS along with the resonance hybrid, and after doing that, just inform me once so that I'll solve that. Guys, formally we have ended up the chemical bonding, finally. Okay. Yeah, we have to practice few more questions based on the resonance. Okay. But we have ended up the chemical bonding. By the next class, I'll start with the states of matter, which is the next chapter, gaseous state. Okay. You guys are having the examination in the fab now? That's what you were saying last time, if I'm not wrong. Satna and Shillong, please confirm me once. You are having the exams in the fab, I guess in the first week or in the second week. Or it is in the March. Wow. Actually, I have already stated the two statements. Now you have to write either Feb or March. Okay, Feb last week, the Satna. Okay. First week of March. Okay. Wow. Have you copied that, guys? Have you done that? Guys, first of all, tell me, is syllabus in your school has been completed, or will it be completed in the next 2 months? And I guess so even you are having the holidays as well, uh, in for the, I guess, Christmas. How is it possible that your schools will complete your syllabus in the end of the January? Okay, yeah, I'm getting it, Satnam, that how is that possible? What about you, Shillong? What is current chapter running in your schools, Satna and Shillong? Few chapters means, have you completed with the first book? Which chapter is currently running? Just let me know. I guess so they were following the sequence, na? First of all, they have taught you the some basic concepts and structure of atom, then periodic table, then the chemical bonding, then states of matter, then thermo, equilibrium, redox. And this should be the sequence, na? Which chapter is running right now, Satna and the Shillong? What? Are you serious? Have they completed all rest of the sections? Means they have completed up to the P blocks of the second book. Wow. Okay, guys. Let's focus on this question. 1, 2, 3. Draw the structure. Okay, some with equilibrium, some with the P block. Wow. Okay, so actually what will happen? This bond will shift it over here, and this one will shift here. So here you will get the electron pair with negative charge. You will develop positive charge, lone pairs, and a double bond. Okay, and last double bond was definitely here. And again there is a conjugation. Okay, so obviously this time you will say this is 1, 2, and 3. So shift this one here, and this one here. Will it be possible? This is double double bond. Double bond. No, this is not possible structure. This is not possible. Okay. So this is the possible structure for this one. Okay. How many of you have drawn the same? This is the only possible structure for this one. Example number 7. Now, guys, are you having any doubt about this one? In the last structure, octet of oxygen has been exceeded over there. That's why that won't be the possible structure. Okay. Now, let's check out this one. That CH2 double bond CH2 free radical. Okay. So guys, remember one thing, we need to draw a double bond means to draw a bond, a single bond, I need two electrons. Okay. So in such cases where free radicals are involved, actually we make the homolytic fission. Fission means breaking. Okay. This one-sided arrow is representing that the electrons, see, this was the shared electrons. Okay, One is electron given by one carbon and second one is given by the central carbon. Okay, so they both will take up their own electrons, and after doing that they will look like this: free radical, free radical, free radical. Now what will happen, that these two will combine with each other to form a bond, and actually it will look like this. See, 1, 2, 3. Okay, remember in the examination need not to draw the structure which is I have drawn at the bottom. Means this is just an explanation for this one. Please copy. Is it clear to everyone? Is there anyone who is having the doubt? Please copy. After that, one important question for the exams. Done? Okay. Tell me. This is the number 9 now. Can we draw Lewis structure for this one? Sorry, what I'm saying? Not Lewis structure. Resonating structure. Can we draw the resonating structure for this one? Okay. Anyone else? Okay, let's start. Actually, look at this case. Okay. What actually I was trying to say, that Z, where it contains a positive charge, a negative charge, a radical or free electrons. Just after that, there must be a sigma bond, and just after that, there must be a pi bond. This should be the condition. What? Electron pairs. And after electron pairs, there must be the sigma bond. And after the sigma bond, there must be the pi bond. This is the actual scenario. This should be present. If this is present, I can draw any of the resonating structure. Now let's try to satisfy this condition. Let's see what will be there. I'm considering this one is as a Z. I'm saying it is 1, it is 2, and it is 3. Yeah, this is definite. This can be the Z because it contains the lone pairs. Tell me, whenever there is a double bond, can I say there must be a sigma bond as well? I know pi bond can never exist without a pi or sigma bond. So there should be the sigma bond. Okay. Now, in the next structure, you can definitely say there is a pi bond. Means between the two next two atoms, you can see there is a pi bond. So actually the conjugation is lone pair, then the sigma bond, then a pi bond. I think this is satisfying over here. And if this is satisfying over here, it means I can draw. Okay? And yes, I will draw. See? I'll do the same. First of all, draw the single bonds, and after that, between 1 and 2, there will be the extra bond. See, 2 bonds were already there. I'll draw 1 extra bond. Okay? Between 2 and 3, there were 2 bonds. I'll make the single bond. Okay? Now, how is that possible? If I shift this electron pair here, this one will develop positive charge with lone pair. Obviously, this one has to be shifted here, and this one will look like this. Now tell me, now is it possible? Have you understood? Interesting? Please copy. Okay. Okay guys, so finally that's all about your chemical bonding over. Nothing more to be discussed. Okay. And I hope so everyone is clear with the resonance. Okay. You have understood the concept of resonance, that how we can draw the resonating structures. Okay. So let's do a little bit of more better question. Let's say suppose we have got this one. I hope so you can attempt this question. Please. Take 2 minutes, 3 minutes. Always you have to do 1, 2, 3, 1, 2, 3. Only you need to count up to 1, 2, 3. This should be the 1, this should be the 2, this should be the 3. That's it. Just make 1, 2, 3, 1, 2, 3, 1, 2, 3 till the case where you won't get structures which are repeating, which starts repeating, means which are already present, that you have already drawn. Let's start this question. Please do that question. In the organic chemistry, I'll discuss only the stability of the residue structures only. I won't tell you that how to draw the resonating structures. Please keep in mind. Just inform me once after doing that. Or if you want me to solve this, please just let me know. I can solve one question for you. Have you done that, guys? Okay, let's start. Just look at this, 1, 2, 3, 1, 2, 3. And let's start with the 1, 2, 3. See? This should be here, this should be here. After that, there must be the double bond. Here should be a positive charge. There must be electron pair with a negative charge, and this is double bond. Again, I can say this is this should be the double bond. This one should be the lone pairs. After that, just shift this one here, this one here. At last, this one should be shifted here and this one should be here. And finally, we'll got this one. After that, no more possible structure. So that's why this is over. So in total, I can have the 5 structures. How many of you have done the same? There can be the total 5 structures. Please copy. See, I haven't mentioned the 1, 2, 3, 1, 2, 3. You can mention it 1, 2, 3. Okay. Just for the better understanding. 1, 2, 3, 1, 2, 3, 1, 2, 3. Anyone having any doubt, please inform me once. Any doubt? Okay. Look at this one. Attempt this one. This time, yes, this is 1, this is 2, this is 3. Attempt this one. Last question of the resonance. Done? Okay, let's start. So this bond would be shifted here directly, and after that it will look like this. Double bond, CH2, positive, this one. After that, this one will be shifted here. Positive, double bond, double bond, double bond. This one will be shifted here. Positive, double bond, double bond. After that, this one will be shifted here. Again, I can have the 5RS. Please copy. Any doubt? How many of you have done the same? How many of you have done the same? Okay, Satna. Very good. Some. It's okay. I hope so it is getting clear to everyone. Please guys revise it again at your home. Okay. A really important concept for the examinations. I'm telling you. Okay. So guys, I guess so time is over now. Okay. Okay, that's really nice, Shillong. Okay. I know you guys are really smart. Okay. Okay, so guys, let's wind up today's session. Thank you so much. I'll see you next time, guys. Okay. Till then, take care. Bye-bye. Good night.